This is the lecture number 9, conformal mapping. Everyone, everyone known that what is the mapping? Okay, mapping is a, for this firstly we define two sets A and B. Suppose define A and B and then it is a rule from set A to B. For this, for each and every element of A has a unique image. This is called the mapping. Okay, and but conformal mapping it is for the complex variable. Before that, we know that the what is the elementary some elementary transformation of the a, a conformal mapping. Then we discuss the what is the conformal mapping. Okay, I will share the screen for all of you. Okay. Uh, you can see here. Here is the preservation of the angle. Preservation of the angle, but it is too complicated. I will go in the simple way. Okay, the topic is the conformal mapping. And what is the conformal mapping? It's written is very complicated. Okay. Before that, uh, yes, a transformation. A transformation. What is the transformation? Transformation is a just a mapping. Suppose we transform the complex number w by z square. It is called the transformation. Okay. So definition for the conformal mapping is the a transformation w is a function of z is said to be conformal if it preserves angle between oriented curves in magnitude as well as in orientation. Therefore, we discuss the elementary transformation. What is the magnitude by behalf of the magnitude, by behalf of the orientation, and so on. Okay. So for this, it means it preserves. A transformation is said to be conformal. It's mean a w equals to function of z if it preserves angle between oriented curves, angle between oriented curves in magnitude as well as orientation. Okay. Okay. In the conformal mapping, a transformation w equals to said to be conformal if it preserves angle between this and this. And note from the above observation, if f is analytic in a domain D, if f is analytic in a domain D and z naught is a point belongs to D with its derivative at z naught not equals to 0, then f is conformal at z naught. तो एक ये भी आइडिया है कि यदि f एनालिटिक है और उस z नॉट पे फंक्शन का डेरिवेटिव नॉन जीरो है तो f जो है हमारा कॉन्फॉर्मल होगा एट z नॉट पे. एंड द नेक्स्ट थिंग इज द let fz equals to z bar, then f is not a conformal mapping as it preserves only the magnitude of the angle between the two smooth curve but not orientation. Okay, अभी हम देखेंगे क्या मतलब है orientation का. Such transformation are called the isogonal mapping. And the second example is the let fz equals to e to the power z, then f is a conformal at every point in C as f dash z equals to fz this equals to the power z. क्योंकि ये जो है एक प्रकार से देखा जाए एंटायर होता है, तो जो एंटायर होगा वो तो कंफर्म है कि कॉन्फॉर्मल होगा. जेड बार की बात यदि मैं करूं तो एक्स माइनस आयोटा वाई, ठीक है, एक्स माइनस आयोटा वाई की यदि बात करूं तो जब कंपेयर करूंगा 1 मिलेगा, वाई का 0 मिलेगा, तो 1 मिलेगा, तो यू एक्स इक्वल टू वी वाई नहीं होगा, है ना। यू एक्स इक्वल टू वी वाई मतलब सी आर इक्वेशन को सेटिस्फाई नहीं करेगी, इसलिए ये जो है कन्फर्मल भी नहीं होगा। ओके, next thing is the if we're taking the function f of z equals to sin z, this is the conformal map except 2n plus 1 pi by 2. And what is the scale factor? Okay, if f is analytic at z naught and f dash z naught equals to 0, then the point z naught is called a critical point of z f, and the behavior of the analytic function in a neighborhood of a critical point is given by the following theorem. It is the scale factor. You can see here, and he is a proof. Is a proof here. Our main motto for this to discuss the only a conformal mapping by using simple way, in a simple way. Okay, now we come to the book Preservation of Angle. Let C be smooth curve represented by the equation z equals to zt, and let fz be a function defined at all points of z on C. The equation w equals to function of zt is a parametric representation of the image of C under the transformation w equals to f of z. This is the, you can see from the angle is also. Because of this angle preservative property, a transformation is said to be conformal at point z naught if f is analytic there and its derivative not equals to 0. And such a transformation is actually conformal. A transformation w equals to f of z defined on a domain D is referred to as a conformal transformation or a conformal mapping when it is conformal at each point in D. That is, the mapping is conformal if f is analytic and its derivative has no 0 here. तो यही है कि मतलब कन्फर्मल प्रूफ करने का मतलब यह है कि एनालिटिक हो और इसका डेरिवेटिव उस पॉइंट पे 0 नहीं होना चाहिए। Therefore e to the power z is conformal क्योंकि ये एंटायर होता है और यदि इसका डेरिवेटिव ले तो ये कभी 0 नहीं होगा। Consider two smooth arcs which are level curves, isogonal mapping. And the transformation w equals to z bar is a reflection in the real axis is isogonal but not conformal because that this is the not analytic. Example number 4, the point z equals to 0 is a critical point of the transformation. W equals to 1 plus z square, which is a composition of mapping z square and 1 plus z. Moreover, the angle between any two rays draft from the critical point is doubled by the transformation. Scale factor, another property of the transformation that is conformal at a point z naught is the obtaining by the considering the modulus of the derivative of the function at z naught. Although the angle of rotation argument f dash z is called the scale factor point to point. When fz equals to z square, the transformation equals to x square minus y square plus iota 2 times xy is conformal at the point z equals to 1 plus iota, where the half line 1 plus iota. Why? Its derivative, if you're taking its derivative 2 times z, and this is the 2 times z, it is the 2 times z is the 2 1 plus I. 5/4. Okay. Before this, we start the some another book. Okay. Some elementary transformation. First is the translation. Everyone known that what is the translation, w equals to z plus alpha. यदि मतलब z है और यदि w को आप चेंज कर रहे हैं z plus alpha, alpha is any arbitrary constant, this is called only the translation. And for rotation, we can write w equals to e to the power I theta z. Magnification, we can write w equals to c times z. And the rotation and magnification, w equals to beta times z. Beta is the complex number. Okay, magnification and rotation, beta is the complex number. Okay, inversion, w equals to 1 upon z. Okay, for this we can see an example. Find the image of the infinite strip. First is the 1 upon 4 less than theta less than half. Second is the 0 less than theta less than half, or under the transformation w equals to 1 upon z. Show the regions graphically. Since w equals to 1 upon z, therefore u plus iota v equals to 1 upon x plus iota y, and we solving them, we get the u equals to x upon x square plus y square, and v equals to minus y upon x square plus y square. Then u by v equals to minus x by u, x by y, so x equals to minus u y upon v, and v equals to this, and this is y. Therefore, in the first, if the first expression, if we put the y equals to 1 upon 4, this is give the y is the minus v upon u square plus v square equals to 1 upon 4. It gives the u square plus v square plus 4v equals to 0. This gives the u plus v plus 2 square equals to 4. Thus, the line y equals to 1 upon 4 is transformed into the circle. ये होता है कन्फर्म, मतलब कैसे आप इसको चेंज कर रहे हैं. If you taking the y equals to half, then it is the minus v upon u square plus v square equals to 1 upon 2. This gives the u square plus v plus 1 whole square equals to 1. This is the transform into the circle also, and therefore the infinite strip 1 upon 4 is less than y is less than 1 upon 2 in the z plane is transformed into the region common to the circle. U square plus v plus 2 whole square equals to 4, and the u square plus v plus 1 whole square equals to 1 in the w plane. The two regions are shown in the following figure. तो कुछ नहीं करना है, बस एक स्ट्रिप बनानी है और यहाँ पे आपको सर्किल ड्रा कर देंगे. And the second question is the y is greater than 0 and less than half for the 0. For the 0, v equals to 0. Okay, and v equals to 0. Therefore, the uh, and for y is 1 upon 2, everyone known that this is the circle. Therefore, it follows the figure that the circle gets bigger and bigger as y diminishes from 1 upon 2 to 0. So hence infinite strip 0 is less than y less than 1 upon 2 in the z plane is transformed into the region outside the circle in the lower half of the w plane. The two region are shown in the following figure. Okay, यदि हम y यदि हम greater than 0 put करेंगे तो v is the v is the negative, therefore this is. And what is the linear transformation? A transformation of the type w equals to alpha z plus beta, where alpha and beta are the complex constant, is known as the linear transformation, and this transformation is the resultant of the magnifications, rotations, and the translation. To obtain the resultant transformation, we first magnify the region in the z plane by the factor a equals to mod of alpha. Then we rotate the region so obtained through an angle lambda, and finally translate the region so obtained parallel to vector beta through the distance mod of beta. A conformal mapping. Let under the transformation be the point. What is the definition of the conformal mapping? Everyone known that a conformal, for the conformal it is conformal if it preserves the angles and rotation. Necessary and sufficient condition for W equals to function of Z to represent a conformal mapping. First is very important. If W equals to function of Z represents a conformal transformation of domain D in the Z plane into a domain D dash of the W plane, then Fz is analytic function of Z in D. Must be analytic. Therefore, U and B must satisfy this Cauchy-Riemann equation. And second is the Fz be analytic function of Z in region D of the Z plane. And let its derivative is not equal to 0 inside D, then the mapping is the conformal at the point of D. For this, note that if Fz is analytic at Z naught and its derivative at Z naught not equals to 0, then under the transformation W equals to function of Z, the tangent at Z naught to any curve C1 is rotated through an angle theta naught. The distance of the point Z1 on C1 from the point Z2 is the magnified by the magnitude of the derivative at Z naught. Example number 11, prove that the transformation U equals to square root x square plus y square plus x to the power half, and V is the square root x square plus y square minus x to the power half, satisfies the conditions of the conformal mapping of Z plane to W plane, except at Z equals to 0. Proof also that the angle at the origin are doubled in the passing from W plane. The given transformation, we write the value U and B. Now we changing to polar system, we get the U equals to R plus R cos theta to the power half. This is the U equals to square root 2R cos theta by 2. And then we get the partial derivative of U with respect to R and theta. We get the delta U upon delta R equals to root 2 upon 2 square root R cos theta by 2. And delta U upon delta theta equals to minus 1 upon 2 square 2R sin theta by 2. And similarly, we get the B equals to R minus R cos theta to the power 1 upon 2. And similarly, we get the value of delta V upon delta R, delta V upon delta theta. And we can see that the uh, U theta, U R is the 1 upon R V theta, and U theta equals to minus R V R. Therefore, this function is the analytic everywhere except at Z equals to 0. Z equals to 0 प्रॉब्लम है और कहीं प्रॉब्लम नहीं है. Okay. And for the second part, we have to obtain its derivative. For its derivative, we can take its derivative is the defined. Therefore, this is the conformal. Second part, what is second part? Second part is the proof that the angle at the origin are doubled in the passing in the W plane. Let W equals to R e to the power I phi and Z equals to R e to the power I theta. Putting this in equation number 1 and 2, we have this in this, and tan theta equals to 2 pi. Inverse point with respect to a circle. It is important in the conformal mapping is the inverse point. How to find the inverse point? For this, we take an example. Formula is that, suppose gamma be a circle with radius R and C, center is C. 2 points A and B are collinear. C are said to be inverse point with respect to the circle. For this, formula is, formula. Okay. So we come to the question. For question, oh, okay. Question is that the image of the unit circle mod z equals to 1 under the transformation w equals to 2z plus z square. Okay. So the image of the point, it is circle or straight line or parabola or cardioid. W equals to 2z plus z square. W plus 1 equals to z plus 1 whole square. It means we write w plus 1 equals to r e to the power I theta. Then mod z equals to 1. Sorry. Uh, z equals to e to the power I theta is transformed into the curve, and which is the image curve. This is the cardioid. Okay. For the conformal, it is the very important is the bilinear transformation, and it is discussed later. Some objective type question. Firstly, we see that the some exercise in this book. See on screen. Determine the angle of rotation at the point 2 plus I when the transformation is w equals to z square. Put value z 2 plus iota square 4 plus I square plus 4I. This is the 4 minus 1 3 plus 4I. Angle is what? 4 by 3 to tan inverse 4 by 3. Scale factor, find out its derivative. It is the 2z, and 2z means 2 plus I. It means the its magnitude will be 2, and 4 plus 1 are 2 root 5. This is the proof that. And question number 2, what angle of rotation is produced by the transformation w equals to 1 upon z at the point? If we put the z equals to 1, we get the 1. W equals to 1, it's mean u equals to 1 and v is 0. And tan inverse 0 upon 1, this is the tan inverse 0 upon 1. Okay. Angle of rotation. 1. No. 1, we can write 1. It is the e to the power I pi. Okay, therefore the rotation is the pi. And for the z equals to I, 1 upon I, and 1 is the minus I square. This is the minus I, and minus I we can write minus I as a e to the power 0. No, 1 upon I, and I से मल्टीप्लाई करेंगे माइनस आई, और माइनस आई का मतलब होता है पाई, एंड इट इज 0. Minus I. This is the magnitude is the 1, but what is the angle of rotation? Angle of rotation will be minus I. For minus I, what will be the e to the power I pi? It will be the I pi. No, no. It will be the minus I if the pi by 2 sin 0. माइनस आई कब मिलेगा? जब हम लिखेंगे e to the power 0 to the power 3 pi by 2. So we can see the some question. on screen. Find the local inverse of the transformation. Z not equals to 2. Z equals to W की power 1 upon 2. Local inverse means we find the value of Z in the term of W. Therefore, Z equals to square root W. Square root W equals to square root rho to the power I 5 by 2. For C is also I 5 by 2. What will be the angle difference? Okay, this is the some exercise for a student, but my focus it is on question. Question is like objective type. If W equals to function of Z represents a conformal mapping of a domain D, then Fz is what? Represents a conformal mapping of a function domain D, then Fz is what? Option number A is analytic. Option number B is not necessarily analytic. Okay, and option number C is not analytic, and D is the none of above. Option number A is correct, analytic. Question number 2 is a translation of the type W equals to alpha Z plus beta, where alpha and beta are complex constant, is known as the translation, magnification, a linear transformation, and the bilinear transformation. This is the linear transformation. The angle through which a curve drawn from the point Z naught equals to I is rotated under the mapping W equals to Z square. The angle through Z naught is the I. We put the value of this. This will be I square. This is the minus 1. Minus 1. Minus 1. It convert into the e to the power something. It is the minus 1. Magnitude minus 1. Minus 1. So minus 1. So 0 upon minus 1, this is the 0. It is the tan 0. Therefore 0, and minus 1, we getting this minus 1 is the sine is 0. It is the term of the sine pi. Sine pi. Therefore option number B, it is the pi. Sorry. I square. This is minus 1. Minus 1, it will getting minus 1 is the minus 1. It is the minus 1, and minus 1 it is for only, uh, we can write e to the power uh, cos pi. Cos pi. Answer will be pi. Which of the following is the bilinear transformation? It is not part of my circle. Inverse. Okay. Some of the question is here. Condition of condition of conformal mapping. It is very important. Its Jacobian from of u v with respect to xy is non-zero. It is very important. W is a function of z. Therefore, we write Jacobian is non-zero for the conformal mapping. Okay. Mapping fz equals to z bar is conformal, isogonal, neither conformal. Conformal तो नहीं होगा क्योंकि ये z bar is not analytic. Therefore, it is the isogonal. Part B is correct. जैसे बहुत सारे क्वेश्चन है. Student, uh, see the carefully. Question based on the conformal mapping only. In the next case topic, we discuss the Mobius transformation. Mobius transformation is the main application of the conformal mapping. Okay. So we focus on the exercise given in this question. Okay. Thank you.